Hello everyone. I'm very excited to start transaction in this video because everything before transactions that we covered in this playlist, I had already solved everything twice before, once in Java and once in C Sharp, and only then did I start recording videos. But this transaction stuff, it's new to me, and I had a lot of fun implementing transactions the way Redis implements them, and I've already solved everything and I'll be making videos on this transaction extension coming up. So this is where I left you, and it just took me one night to complete the entire section. So, but recording it will be a lengthy process. So because the multi-exec and the transactions, concurrent transactions are pretty complex. So I'll break this down into I think 3 or 4 videos. So stick around for that. Anyways, let's start implementing support for the incre command. So the increment command, it just increments an integer value by 1. So if there is a integer value for a key in my hash map, I just need to increment its value. So let's just read what they tell us. In this stage, we'll add support for the incr command. The incr command is used to increment the value of a key by 1. Example usage set foo5, okay. Incur foo, it returns a resp integer 6, it incremented 5 and returned 6. If the key doesn't exist, the value will be set to 1. So if, yeah, okay. So instead of setting the value to 1, what I'll do is I'll set the value to 0 and then increment it. So if I'll get, so whenever I get an increment command, I'll get from my hash map. And if getting from my hash map results in null, I'll set 0 for that key, and then the process further will be same for both the cases if the key existed in the map or not. So that's just what I'm just letting you know. That's how I'm going to support that. And we'll split the implementation of this command into 3 stages, but I plan to cover all those 3 stages in this video. Key exists and has a numerical value, key doesn't exist, and key exists but doesn't have a numerical value. So we'll do all these 3 things in this video. Let's just see how they're going to test our code. They just run our code as a master node. Another thing I should let you know is that slave nodes don't support transactions completely because sending set write commands to a slave is not possible, right? A slave doesn't process write commands. Therefore, transactions primarily are only done on the master node, and we'll be adding support only for the master node. All right, because we need to increment values so that and set values, whatever. So we'll add that only in our master instance here. So now we see the benefit of splitting the implementation code for master and slave. And technically we should also have an interface that should be common for this, and we should be injecting it via the interface, but I'm not doing that, not too bothered about that. Anyways, let's see what the other stages have us doing. In this stage we need to handle the case where the key doesn't exist. So whenever the key doesn't exist, as I told you, I'm going to set 0 in my hash map, and then the process remains the same for the previous stage. We don't need to do anything else. If the key doesn't exist, I'm just going to set 0 in the hash map. That's it. And let's see what is required in the third stage. In this stage, key exists but doesn't have a numerical value. So what we can do to handle that is we can do integer.parseInt, and if that throws an error, then we know it's not an integer, and in that case we can return this error. So errors are encoded like this in the RESP serialization protocol, which starts with a hyphen R, then the error message, and then ends with the /r/, and we'll just hard code it for increment command. So we already have a plan for what we need to do, so let's get to it. So the increment command is not supposed to be added to the slave implementation because it's a write command, and the slave doesn't support write write commands. So we'll just add it in the master TCP server. So here we have a switch case, right? And in this switch case, we just need to add the incr command. That's it. So what we can do is just copy it, come down, paste incr, and instead of calling ping, we can call INCR. Now this method doesn't exist. I'll create it. Okay. And in this method, what we need to do is we need to first check if the key exists in the hash map or not. It's quite easy to do. Let's just get the key out from the command array. The key will be command of one. So string key, that'll be the key. And let's create a res that I'll return from this method. Return res. All right. Now here, as I said, I'm going to try to parse whatever the value is into integer. So I'll wrap it around in a try catch block. And if we get an error, then that means that the value in the map is not an integer. And in that case, we need to return this error message. So I can simply res equal to, let me just copy it, this. That's all we need to do here. Oh crap. Anyways, okay, that's it. So that handles the third edge case, whatever the second edge case, the third stage here. We have handled that already now. And here in the try, I need to get the value from the map. Now I'm getting the okay, let me explain. In this one, I told you I need to set, in case the value doesn't exist, I need to set it to 0. All right. And if that is the case, if it's missing, I'll just set it to 0, right? So how can I check if it doesn't exist? If I do store.get of my key, it returns a string. And if I get a string from the map, I'll need to call the store.set method as well to set the value back into the map after I've incremented it. But I don't want to do that. Those are two method calls to my repository method. So instead what I'll do is I'll create another method that returns the value by reference, and I'll just update the value once after getting it from the map. So it will prevent two repository calls. All right. So what I'll do is I'll create another method, store.get value, and it will return the value object instead of the value.val parameter, and I'll pass it the key. And let's just create this method, create method in store. Okay, so almost everything is going to be same here. Let's just copy it, and instead of returning this string, I can return here null, I can return null, and here I can return value. That's it. So I can check if the value is null. So if value is null, I need to set 0 in my map, right? So I can do store.set whatever the key is and passing a 0 to it. We don't have any expiry on this because we are creating this value, and we were not sent any expiry by the client. And I can then do value is equals to store dot get value of the key. Now why do I need to do that is when I call this set method, this will have created a new value object and would have put it in the map for that key. So I need to get that reference out from the map. That's why I need to get to this, and I can get the val like so, integer dot, I told you I'll do parse int of value dot val. All right, and if this throws an error, we'll go into the catch and return the result But if this passes, I need to increment the val, and I need to set yeah, value dot val equal to val. Why is it throwing an error? Yeah, because it's an integer, I need to convert it back into a string. And now I can set result is equals to resp serializer. We already have a resp integer method that will do the resp serialization for an integer. And I think we are good. We have handled all the three cases. Let me just review the code. I think we are good. Anyways, let's just try. Push and try. So I think this should pass all the next three stages. Paste. Git push. Let's see the logs. We didn't change much. The build should pass. Build succeeded. So the increment command is pretty simple, but the stages that follow the increment command, the implementation of the multi command and the exact command and the discard command, they're very interesting. Especially these two stages, queuing a command and executing a transaction. What we'll do is we'll implement a sort of a event loop kind of thing. We'll implement a queue and we'll push commands into the queue and then pop out of it, and then we'll have a separate cache on which we'll try to implement those commands and then dump that to the original data store so that we can roll back in case required. Anyways, I'll talk about that in the next videos. Let's see the logs. Yeah, you can see the tests are passing. All the three next stages should pass if I've done everything right. By that I mean is I've already created a PR, and this is the script I use while recording the videos. I create a PR and then see the changes I did and do those live again. That's it. Anyways, this PR allowed me to pass the three stages. So I think it's done. Let's see the other two stages as well. Okay, so this video is gonna be a short one, I suppose. We'll talk about the multi and the exact commands, how they work. We'll read what the material they've provided us, and I'll talk about how we are going to implement it. All right, and I can even show you the code because already everything is ready. Okay, we'll do a little code review. We'll see what is required of us. We'll do a little code review of what I did last night, and in the next video we'll implement it live, like from like we'll solve these stages from scratch, from where I left you guys off in the previous video, or will I leave you guys off in this video? Alright, this stage passed, we are next stage. This should pass as well. Let's see the logs. It'll not show the logs. But it will pass, I know that. Anyways, let me open the next PR. So even though this transaction stuff is pretty complex, it didn't take me much time to actually implement it. I got back from work yesterday and started working on it. And I started working on it around 12 at night. It just took me 20 minutes to solve this increment command stuff. And then I've been working ever since then to solve the transaction stuff. Let me show you the PR for that. Let's do some code review. Okay, so that these three stages have passed. Let's see what's required of us in the multi command, and I'll show you how I'm going to tackle that. So it took me few hours to solve it. I've worked at it till 2 at night, and then since the morning. Took me about 5-6 hours, I suppose. Shouldn't have taken that long, but I was conflicted between architectural decisions, and that's what took up my time, and I changed the architecture quite a bit between these. And it was also required to prevent deadlocks. So pretty important stuff anyways. So let's just read what the multi-command does. So after a multi-command is executed, any further commands from the same connection, and by connection we have client in our context, we have a client object. So only one multi-command is allowed for a client. Okay. And after the multi-command, any commands that follow it will be queued but not executed. Right. Like so, when they send a multi command, we return back with an OK. Then they send a set command, and we just return back that it's queued. Then they send an increment command, and then we just return that it's queued. The queued commands can be executed using the exec command. Okay, so after the multi command, we'll have initialized a queue, and in that queue we'll have stored all these commands, and whenever we get an exec command from the client, we'll just pull one command out of the queue one at a time, and then keep applying them. And that's essentially how the transaction works. In this stage, you'll just add support for the multi command and return an OK. We'll get to queuing commands in the later stages, so it's a pretty easy one. Let's just read what the exec command does. In this stage, you'll add support for exec command when the multi command has not been called. So when we get an exec command without there have been a queue initialized for that client, the client returns back that error exec without multi. And similarly for discard as well. In that case as well, if transaction has not been initialized and we try to roll back or discard the transaction, we return back with error discard without multi. That's it. And it looks like this. That's all the information they have provided in this stage. And the empty transaction. If exec is executed right after the multi command, we return back with an empty array. And an empty array in RESP serialization protocol looks like this. Right, so we'll get a multi command, then we'll get an exec command, and we need to immediately return back with 0. Right. Queuing commands. So any command that follows the multi command will be just offered into a queue. That's it. That's all we need to do in this stage. Breaking complex features down into these small tasks is essentially what software engineering is all about, and that's what makes it solvable. If you try to tackle everything that a transaction can do, it's pretty daunting, and I don't think I can do that, at least. But seeing it like this, it broken down into small chunks, it gets easier, and that's why I love CodeCrafters. Anyways, executing a transaction, when we receive an exec command, we just pull out of the queue and then start implementing those commands onto our data store. So let me show you now the code that I'm talking about. All right. So like I said, one client can only have one transaction. So we'll create a boolean in my client class that will hold true or false. And the true means that the multi command has been executed and we are in a transactional context. That's why I'm calling the variable transactional context. If it's true, then we are in a transaction and all the commands need to be queued into this queue that I'm creating right here. Okay, so all the commands that are in a transaction, they give a response, right? We get a response from a set command. We get let's say we got two set commands. So when we execute those two set commands as part of a transaction, they return two responses, and both of those responses need to be returned together in a resp array. So it'll be an array of size 2, and the first element will be the response of the first set command, and the second element will be the response of the second set command. So I'm storing those responses in this list for the first and the second set command, whatever. These are just some getters. And I've created this method called begin transaction. What this will do is it will begin the transaction for the client from the perspective of the client. So what it will do is it will set transactional context to true, and it will initialize the command queue. And this end transaction method, it will just set the command queue to null, and the garbage collector will clear the data, and the transactional context, it will set the transactional context to false. And we just need to add some send methods as well. I'll talk about those later. This is the important stuff. So in my master TCP server, okay, yeah, here. So we had this handle command. Now I've changed this handle command quite a bit. All right, let me show you. The code that you have, if you've been following me, looks like server, master TCP server. We have the handle command, and the handle command method looks like this, right? It has a switch case in it. Now I've changed that quite a bit. So in this handle command, we'll check if the client is in a transaction. If it's not in a transaction, we can process the commands like we have been processing the commands. So that I have extracted out into a method called case handler, and then we'll returning whatever the response is back to the client. If we are we'll get here, the control will come here if we are in a transactional context. Now if we are in a transactional context, an exec command should should commit the transaction, and the discard command should roll back the transaction. So we need to add special consideration for those two commands, and that I'm checking right here. This uh, transactional control command method is just returning true if the command. Yeah, let me. It's not quite readable, right? Ah, my eyes. Anyways, look at what I do for you guys. I'm burning my eyes. Anyways, if we have exec on a discard command, we're just returning true here, else we are returning a false. And that's all that this method does. So we're checking if it's a exec or a discard command. If that is, we're calling a method called add command to transaction. If that is not the case, sorry, if the command is not an exec or discard command, then what we need to do is we need to offer all the commands into a queue, right? That's what we've been discussing. So let me show you that method. All it is doing is offering the command into the queue and returning the queued response back to the client. All right. Now comes the bulk of the transaction. All right. So if that is not the case, if we got if we were in a transactional context and we got an exec command or a discard command, the control will reach here. So if the command was exec, let me show you that later. Let me first show you one thing. Yeah, in my case handler, if we will get control in this method only when we are not in a transactional context. Right here, if not client.get transactional context, right? So control will only come here if you're not in a transactional context, and in those cases the exec and discard command should return these error codes, and we will also receive a multi command here in this method. And if we get a multi command, we just need to begin the we just need to call this client.begin transaction method that will set the transactional context to true and initialize the queue, right? And then we just need to return a result. Let me see what else is here. Yeah, that's it. And now let's look at how the exec command works. Let's see how the discard command works, because that's pretty easy. All we need to do here is call client.end transaction, because that will clear up the queue that we had created, and it will set the transactional context to false for the future commands. Okay, so we will not process the queue, it will be cleared by the garbage collector. That's all we need to do for the discard. Now for the exec, if the queue is null or the queue is empty, we need to return back with an empty array, and then we can end the transaction. Okay, I just told you why we need to send, because that's what's required of us. We'll get to that soon enough. You don't need to mug this up. I'm just doing a little code review. And then what I'll do is I'll create a new queue out of the client.command queue. Why? Because we'll be pulling out of the queue, and we need this queue twice, because see, we need to roll back in case some error happens, right? That's what a transaction is. So I need to first verify that all the commands in my transaction queue will pass without any error. So I need to poll from my queue to verify the commands, and then I need to poll from my queue to actually execute those commands. So I need to poll those commands from my queue twice. So I've created this queue. This commands queue right here is just required to verify the commands. All right. And we'll actually use the client.command queue when we are executing the commands. This command array will only be used to verify. That's it. All right. Now here comes something interesting. I'll show you what this command handler.get transaction command cache applier do. Pretty complex name, I know. It returns a reference to a method, and let me show you that method. So right here in my command handler, I created this method, get transactional command cache applier. All right, so this just returns a method. Okay, it returns a lambda method. This lambda method accepts a command array and a map, and it returns a string. So to be able to pass the method reference around, we need to use what Java call it, functional interfaces. So that's why I've used this by function functional interface. It takes a string array and a map of string to value, and it returns a string. So the reference to that method is saved in this command applier, and I've created another method in my store that's called the execute transaction method, and I just pass the reference to the method there in the store. Okay. That's all I'm doing here. And now see, we had created this commands queue, right? So let's see what the store execute transaction method do. So right here, execute transaction method right here. Okay, so what we need to do, see, when we are working with transactions, the important thing to note is that there can be deadlocks, right? While we are executing the transaction might take a long time. Okay, if I have 1,000 commands in my queue and all need to be applied one at a time, then it will take some time. And in the meantime, if I send other commands, if other commands are processed and my store get those commands, my hash map that we created earlier, this concurrent hash map, should not allow reading and writing. But that's not, but we are using a concurrent hash map, so it should handle that on our own. So why do we need this manual locking and unlocking? I'll tell you why. Because to be able to verify the commands, I need to read all the data out from the map. Then I need to sudo apply all the commands and store the result in a separate map. All right. So that, so right here, you see this transactional map. This is just a separate map that holds the data once the commands are verified. Okay, this is we are not actually applying to the map right now, because what happens if we need to roll back? If we need to roll back, the original data would have been lost. So instead, what I'm doing is, if you are working on any key in a transaction, I'm reading that key and I'm storing that, caching that in this transactional map, and then applying commands to this transactional map. Whenever we get the exec command, what we are doing is I'm dumping all the data in this map into my original concurrent hash map that we have right here. So you see, I need to read the keys from my concurrent hash map to verify them, and then I need to write to that concurrent hash map. I need to dump everything into that concurrent hash map. So because I need to read them and then dump, that's why we need the reentrant locks. We'll get to that later. I'm just explaining, bird's eye view, forest for the trees kind of stuff. I'll explain it better in the next video. I'll create a diagram of the sorts and show what I mean. Anyways, I think that's enough for this video. That's essentially the big picture idea of how our transaction will be implemented, at least how I chose to implement it. And it was very, very interesting. I had a lot of fun doing it, and I hope you'll stick around to see that. Anyways, that's it for this video. I'll see you in the next one.